Welcome back, everyone. We're already in section 3 of chapter 1. This time we'll talk about data collection and experimental design. Getting a little bit more interesting, perhaps. Some more foundation work again. And let's get with it. But before we do, take a look at what we've looked at. We looked at what statistics is, how we classify some data, and now we'll talk about how to collect data and how to design an experiment. So you can hit the pause button. Remember, the pause button is a big help, especially when we get to the questions. You can pause it, read through very carefully, make your best guess or answer, and then hit pause again, unpause, and go on. All right, so how do we design a statistical study? Well, it all starts with a question. And that question leads you to step number 1. What variables of interest are you interested in, and what is the population you're interested in? That variable of interest will be the characteristic of the population. And that's what you're interested in, number 1. Number 2, develop a plan for how you're going to get the data. If you're going to have to use a sample, make sure the sample represents the population. Sort of like a mini population that looks like the larger population. That's why it's called a subset. Then you collect the data, maybe surveys, maybe interviews, lots of possibilities, measurements, counting. Then you take that data that you've collected and use descriptive statistics to get charts and tables and so on to show someone what you found out. And next, what about the data? What does that data tell you? What decisions could we make about that population? And since we're using only a sample, it's inferential statistics, because we're using the sample to make a good guess about what's true about the population. And last of all, but not least, in your statistical study, one of the things you need to do is identify any possible errors, because you want to be able to replicate or repeat this experiment. If someone doubts whether your results were correct, and they can do the same thing, and they won't have the errors that you have identified. What kind of studies can we have? Well, the first one is, as a researcher, so there we go. As a researcher, you're going to observe and or measure the characteristics or variables that you're interested in as part of the population. For example, measuring the amount of time people spent doing various exercises. Play, for example. What's different is in the observational study, you're just observing. You're not changing any of the individuals or any of the pieces of the population. In an experiment, you're creating a treatment, and that's a wide statement. You might be giving medicine, you might be combing someone's hair, but you're doing something with that group, and then you see what responses you can observe. Part of this is using a control group. You have an experimental group and you have a control group. You make changes or do something to the experimental units, and then you have a control group in which nothing happens, but the group itself, whether it's 2x4s or whether it's people, they don't know that there's no treatment applied. In some cases, those subjects might be given a placebo. If you think of drugs, for example, you've got a drug that's going to cure ailment XYZ. And to the treatment group, you give the actual medicine. To the control group, you give them what's called a placebo. It's a fake. It looks like the treatment, so both groups think they're getting the actual treatment. So here's an example, and I would suggest you hit the pause button, read through this, and experiment about an artificial sweetener. Of course, this probably has to do with not only overweight people, but possible diabetics. They might be pre-diabetic, they might be type 1, or they might be type 2. All right, question time. Ready for the pause? Okay, hit that pause and see what the researchers are doing. They're researching the effect of vitamin D3. And read through this, and I'll see you in a moment. All right, you're back. It applies a treatment. In other words, the patients are getting vitamin D3, and we're hoping probably that that's going to improve their life in some fashion or another. So it's an experiment. We're not just observing, we're actually doing something with that group. Number 2, ready for the pause? Okay, hit the pause button and read through this. This time it's a study to see how confident Americans are in the economy. And they asked 3,040 US adults. Now we'd be interested in all the adults, but that would take a long time. So we picked 3,040 and we asked them to rate the current economic conditions. So what do you think? Observational study or an experiment? Oh, you back? I hope you chose the observational study because we're not doing anything with those 3,040 adults. We're only asking them what their rate is for the economic conditions. Next, sometimes things can be dangerous or maybe very expensive, so instead we use simulation, usually with computers, not necessarily though. You might have a physical model like with cars. Create a physical model and see what the results are of putting it in a wind tunnel. Usually computers, not always. So if it's dangerous or impractical to do it in real life, but you do need to find out something, simulation is the way to go. Save time, save money. If you're interested in an example of the US Navy, ask me in class, because I worked with simulations for the US Navy involving cruisers and destroyers. And as I mentioned, automobile manufacturers do that, simulating crashes with dummies because you don't want to have crashes with humans and have them maimed or killed, right? Let's do it safely. Let's do it with the dummies, a simulation. Another possibility is taking a survey. Investigate one or more characteristics of a population. Are they employed? How many kids do they have? All kinds of possibilities you could have in your survey. It depends on what you're interested in, and don't forget, it's not just what you're interested in, but what's the population of your target. They're carried out on people. You don't ask robots. Interview, internet, phone, mail, some are better than the others. We'll let you figure that out. But make sure in the survey you word the questions carefully. You don't want to ask them in such a way that you're leading the surveyed people to give a particular answer. and make sure that those people that you choose for the survey are representative of the population of interest. So you could survey a sample of physicians. Why? You're interested in all physicians, but that takes a lot of time. And you want to find out whether they chose to be doctors because it's a financial thing. So you might make a list of reasons and have them choose their first choice. And it's also easier for respondents too, if they have things to choose from as opposed to filling in a blank. Experimental design. 3 important parts. The control, that's the part that doesn't get a treatment. The randomization, any of those could be chosen for your experiment. And replication means you might try that same experiment again and see if you get the same results. But you need written down exactly how you did it, so you or someone else could actually replicate this experiment. Confounding variables. Oh my gosh. We're going to have an example coming up, but for example, you're doing an experiment where you want to find the difference on people wearing different kinds of shoes or different kinds of makeup. Well, you don't want to throw males and females together because you don't know whether what you're doing, the treatment, makes a difference, or whether it's because you've got different subjects, different kinds of subjects. And the example here, and I would suggest you create your own example. Here the coffee shop owner remodels her shop. Maybe, for example, it's a bookstore. And at the same time, a nearby mall has a grand opening. And maybe they have a Barnes & Noble in there. Business at the coffee shop increases. Well, it might because of the remodeling, or it might because there are more people in that area because of the new mall. Confounding variables. Which one is affecting the increase in your sales? I mentioned the placebo effect a little bit earlier. It's when a treatment is a fake treatment. That's what's given to the control group. So you can compare the people that didn't get the treatment with the ones that did. But the people that get the fake treatment or placebo won't know that it's a fake treatment. They will actually think it's the real treatment. To make sure that you minimize the placebo effect, what you want to do is use a technique called blinding. What's blinding? It's when the subjects don't know if they're receiving the treatment or placebo. Double blind means not only the subjects don't know, but the people giving the treatment don't know whether it's the treatment or placebo. Next, randomization. Randomly assigning subjects. And there are different ways to do this. Completely randomized, it's usually a good one. Assign subjects to different treatment groups randomly. And then there's a randomized block design, where you take people in the population or things in the population and group them according to some characteristic. Maybe redheads versus people that have brown hair. You might put them in the blocks like that. All kinds of possibilities. That way you can see how it's affecting the redheads, how it's affecting the people with brown hair, and so on. So this is what the randomized block design looks like. You've got some people, and that's your population. And what you'll do is maybe separate them into the ones in their 30s, ones in their 40s, and ones over 50. So you've got 3 different blocks or groups. Within each group, you're going to have a control group and a treatment group. That way you can tell what happens with 30-year-olds as opposed to 40-something-year-olds. And of course, it's always possible, if it makes sense, to put all those together and see what the grand totals are and how it is for everyone. Matched pairs. Excuse me. This shouldn't be too hard. You get, let's talk about people. So you get 2 people that are very close to each other in height, weight, whatever is important for your treatment. And you match them up. So you've got a whole bunch of matches. And see what happens to the different ones that get a treatment versus the ones that get the placebo. Sample size. Oh, boy, is that important. You'll find that over and over. Number of subjects. And the sample size. Usually, the more you can have, the better. But having more subjects means it's going to take more time and usually more money. So you have a trade-off when it comes to sample size. I've mentioned replication before. It's repeating an experiment using a large group of subjects. An example here. Excuse me. Okay, here's your first chance to answer a question of your own. Hit the pause and see if you can answer the question. How could you improve this experiment? Okay, you're back. That sample size is pretty small. You could use a larger sample size. It might need to be, probably should be replicated because of the sample size to improve how valid your results are. Another chance. How could you improve this one? This time we're talking about blocking according to gender. So you have groups of males, groups of females, and so on. After 2 months, how about the smoking? Some quit, and is it different for the males versus the females? Well, how could we improve that? The groups are not similar. So you'd need a block. I guess I told you in advance. Oh well. New gum may have a greater effect on women than men, or vice versa. So you need to separate them so that you don't have a confounding variable, the gender. Next, a census. And this is where you take the entire population. You're probably familiar with the U.S. Census, which is taken every 10 years, where they try to count or measure the entire population of the United States. If you can't do that, because the census would be a great idea if possible, if not, get a sample. And in that sampling, get a count or measure of part of the population, and it's commonly used in statistical studies because census is usually difficult. Now, it's true. If you're taking a sample, you don't have the entire population included. So there's going to be an error. Almost 100% sure that the statistic you found is not exactly equal to the parameter you were searching for. The difference between the real parameter and the statistic you got is the sampling error. The trouble is, you don't know what the parameter is. That's what you're trying to find. But the sampling error is the difference between those two. And what's a random sample? Now, be very careful about this one and the next one. They sound very similar. In a random sample, every member of the population has the same chance of being selected. Same chance. So we're talking about picking individuals for a sample. Every one of these over here could be chosen. This one could be chosen. Or maybe this one could be chosen. They all have an equal chance of being in that sample. Now remember, that's individuals. A simple random sample is something that's going to be confusing at first. You're going to have to give this a lot of thought. This says every possible sample of some size. Let's say it's size 10 or 100 or 1,000. Every possible way you can put together those 1,000 people has the same chance of being selected as any other group of 1,000 people that you might select. So give this some thought and see what the difference is. In this one, you're talking about each member of the population has an equal chance. In this one, it's every sample has the same chance of being selected, as long as it's the same size, of course. Now, how can you get a random sample? Well, a simple random sample can be pretty easy. You can use, for example, a random number table. And I'm going to show you how to do that. Another possibility is you could use a software program. I don't have any, but you might run into one. SPSS or one of the other ones. R is another one. And another way is using a calculator. If you don't know how to do it with a calculator, ask me in class. I'll be glad to show you how you can get random numbers. What you start with, though, is taking all the objects or all the people that you're interested in and assigning a number to each one. And the people that correspond to these numbers, so you assign these numbers, and then you get random numbers, and those numbers point to members of the population. Those members that you picked become part of the sample. Okay, here's your chance again. Using a simple random sample. 731 students are enrolled in statistics. Now, I don't know how many we would have, but we sometimes have quite a few students taking the elementary statistics course that you're taking right now. You want to form a sample of 8 students to answer some survey questions, because doing it for 731, well, just imagine how much paper you'd have to use. It might get a little bit expensive. So, how do you select the students who will belong to the simple random sample? Well, first of all, give each student a number. 1, 2, 3, 4. Of course, you don't skip any numbers. So every number is assigned every student is assigned a number. Now, on the table of random numbers, this is one way you can do it, and you can do something similar with a calculator or some kind of a computer program. Go to the table of random numbers and pick a starting place at random. So let's suppose you have a big table, it covers your entire desk, and you've got random numbers on that table. And you want to pick random numbers on that. Well, close your eyes and put your finger down on the table That will tell you where you're going to start. So let's suppose this is where your finger pointed. Now remember, you assign numbers to all those students. Numbers 1 to 731. Now this means you have 3-digit numbers. Now the first one will be 001, and 002, all the way up to 730, 731, representing different students. So 3-digit numbers. So you put your finger down in this position. So you're going to start with 3-digit numbers. Well, as you go there, you see the first 3 digits are 719. Now notice also that 719 is somewhere in that list, so it represents some student that we've just now picked. We've used 719. Next to go to the next 3 digits. 662. Again, 662 is in that list of numbers, so you pick that student. Next, you pick 662. The next 3 digits are 738. Oops. 738 is not one of the students. No one got assigned 738. So you just pass by. Skip 738 and go to the next 3. 650. That's a good one. So you pick out student number 650. And we'll go one more. Next 3 digits are 004. So you would pick number 4 in that list and go on until you get how many that you wanted. I think it was 8, whatever it is. You keep going until you get those. And if you see a number repeated, not likely, but you might. If you see one repeated, skip it, get the next 3 digits for another one. So these 8 would make up your sample because you wanted 8 of them. Now, excuse me, this becomes a little bit more interesting because there's some situations where you want to have a sample picked not totally random, not a simple random sample, but in a special way. One of those is called the stratified sample. Now, what does a stratified sample mean? Well, first of all, let's draw a small picture here. Let's suppose this represents the Grand Canyon, and down here is the river. If you look at the side of the Grand Canyon, what you'll notice is there are layers of different colors according to what materials make up that layer. These are called strata. In other words, like stratified. Now, if we were trying to sample the rock or ground or whatever in this side of the Grand Canyon, we would want to pick some of this strata, some of this color, some of this color, some of this color, and so on. You want to make sure that you sample at least one of those different types of strata. So down here is an example that maybe you can connect with better. We have 3 strata. We have low income, middle income, high income. If we choose these totally at random, you might accidentally choose all of group 1 and group 2 and leave out group 3 or not many of group 3. So you won't know enough about group 3 compared to groups 1 and 2. So what you'll do is take a random sample from the first group from the second group, and from the third group. So all of those types of people or things are going to be included in your sample, in your survey. An example here, let me clear this so you can see it a little bit better. There we go. So one way of doing that would be take those socioeconomic levels, low, middle, high, and randomly select maybe 17 from each of these categories. 17 from here, 17 from here, 17 from here. Inside each group, you're going to take a random sample of those. And all of those will go into your larger study. Now this is the one that I used to get confused with a stratified sampling, because it sounds like, well, you've got groups and you're taking a sample, but it's not the same. With the previous one, you group them into important sections you want to make sure you include. In this one, it's a little bit different. In this one, for example, let's take West Ridge County. We're trying to find out something about West Ridge County. And there are a lot of people in West Ridge County, and there are 4 zones. The important part here, and the one that's going to help you, is that if you look at the population or the group of people in Zone 1, they're really no different from the people in Zone 2, or Zone 3, or Zone 4. So if you took a Zone 4 sample, it would look the same as Zone 2 sample. Since those are all about the same, what you can do is pick a couple of those, 2 or 3 of those, and within each one, select a random sample and put those together. Zip codes would be another way. Next, probably the one that you would most likely want to use, because it's really simple. You don't have to worry about the strata, you don't have to worry about clusters. What you're doing is you're going to do something similar to what we did with those 731 students. You've got a lot of members of the population. Remember, they could be 2x4s, computers, or they could be people. It doesn't matter. We're still doing sampling. And what you're going to do is you're going to choose every kth member. What does that mean? Well, k is a number. Maybe every 6th member. So you pick a place here to start with. That's the first one you're going to include in your sample, and then you'll go from there. 1, 2, 3, 4, 5, 6 away from that one, you're going to pick this one. Count 6 again, you're going to pick this one, and so on down the line until you've gone through the entire population. For example, you could take, well, I guess this isn't as good, but we used to have telephone directories. Another thing would be just lists of names. And you start somewhere, and you go every 6th, or every 10th, or every 100th person, and pick them out. That's a systematic sample. Let's clear that for you again. There you go. So you can talk about West Ridge County. We're doing it a different way this time. Remember, before we took low, middle, and income ones and use a stratified sample. This time, we're going to take West Ridge County and have a list of all the houses in West Ridge County, put them in an order, and pick every 6th person. Pick that first one, let's see, where's my, there we go. Pick the first one at random, and then every 100th or 20th or whatever your system is, until you have gone through all of the households. Next, convenience sample. This is unfortunately easy and sometimes used. You choose only members of the population that are easy to get. So you might stand outside the Campus Life Center and pick every third person that comes out. Well, that's pretty easy, but maybe that's during practice, like baseball practice, softball practice, basketball, so those members wouldn't be included. That's the downside of convenience sampling. You usually end up with biased studies because some of the population are not included. All right, here's your self-test. You're doing a study about stem cell research, and you want to see what the sampling method is that's included here. So hit the pause button, give it some thought, and pick which of those sampling techniques was used. See you in a few seconds when you're ready to choose. All right, I hope you're back. Stratified sampling. Notice in particular, we picked majors. Those would be our strata. And randomly select and question some in each of the majors. How about this one? Hit pause again. You're going to give each student a number, consecutive numbers, and generate random numbers like from the random number table, or by using your calculator, for example, or some other method for getting random numbers. So which method is this? Pause for a second and come back with your answer. I hope you said simple random sample. Every student has a chance of being selected. How about if you select students who are in your biology class? What kind of sampling technique is that? You ready? Okay. Convenience. Aren't you being a little bit lazy only getting the biology students? Come on, you can do better than that. Well, we've come a long way. We've talked about sampling techniques, and I hope you have picked up some ideas of things to do and things not to do, and when you might choose one over the other. Well, we'll see you in Chapter 2, actually, next time. In the meantime, make sure you do some of the assignments. Bring your questions to class. In the meantime, keep smiling. Bye.